Hello and welcome. Today we're going to be talking about perpendicular lines. Again, in relationship to transversals and angles formed. This is section 3-4 in the Holt geometry textbook. In particular, having covered parallel lines and looked at the different angles that are involved with parallel lines, the perpendicular lines are actually a little simpler than that because it's really just a special case of everything that we talked about with parallel lines. So if we have two parallel lines and they are cut by a transversal, so again we have our parallel lines which never meet. We have our transversal which cuts across the parallel lines. But in this particular case, we're going to see that line cuts at a 90-degree angle. So if this angle is 90 degrees, based on our knowledge of parallel lines, we can immediately see that, well, if this is perpendicular here, if it's 90 degrees, this is perpendicular, and these two are supplementary, and these two are alternate interior angles, which means they're equal, and vertical, and so very quickly you can see that every single one of those angles has to be 90 degrees, all right, because they are all equal to each other, or they're supplemental to each other, which is the same thing when you are a 90-degree angle, because 90 and 90 is 180 degrees. So they're going to intersect in this kind of special way. In terms of the angle measurements, it's very easy because they're just all equal. In terms of looking at some properties of this, the chapter presents several proofs or kind of theorems around this. Basically all the theorems are saying is, first of all, that if you have a 90-degree angle, if you're told that one of the angles is 90 degrees, then this line must be perpendicular. So that's one of the theorems that they go over. It's again showing, based on what we just did, if all the angles are 90 degrees, then you have a line forming two right angles, and that is, by definition, a perpendicular line. All right? So that's what makes this line perpendicular. Another theorem, I think that one might have a name here. Let's see. If the perpendicular transversal theorem is what they're calling it, and that one basically says that if it's perpendicular to one parallel line, it has to be perpendicular to the other parallel line. This makes sense as well because of, again, the alternate interior angles and things like that. So here, like the corresponding angles, if it's perpendicular to one of these lines, it automatically has to be perpendicular to the other line, all right? Or else they're not parallel. And then finally, the reverse is true, which is that if you have a perpendicular line and it crosses the transversal, then you know that all those angles are 90 degrees. So if you have a 90-degree angle, you can conclude that it's a perpendicular line, and vice versa. If you have a perpendicular line, you can conclude that it is 90 degrees, all right? That those are 90-degree angles. So that's pretty much it in terms of the theorems and the content of this section. As you do some of the problems, they're going to come up with some kind of interesting ways of presenting that. So they have, there's one problem where they look at sort of city blocks, right? And you can think of city blocks as a perpendicular line. If they're all straight lines, then you're basically running perpendicular lines or parallel lines cut by a transversal. So that's one example that they use to look at. Again, if you know what any of these angles are, you can set them immediately equal to 90 degrees. So you don't even have to set them necessarily equal to each other. You can just set them equal to 90 degrees and that will take care of the problem. All right, so that's about it on parallel lines. Thank you so much.
This is Mr. Buzzard signing off.
This is Mr. Buzzard signing off.